It's not Lecture Joe here again. We're going to take a look at a special type of diode called a zener or zener diode. So you'll remember with a regular diode, if we build a circuit like this, battery, lamp, diode, if we put the diode in so that the current wants to flow through the diode in the direction of the arrowhead, then the lamp will light up just fine. Whereas if we put the diode on like this, where the current is trying to flow against the direction of the arrowhead, the lamp won't light up. There'll be no current flow. So for a regular diode, we can only make current flow through it one direction. With a zener diode, this isn't true. We can actually force the current to flow through it, what we would call backwards, if you like. Now the zener diode has a symbol that's slightly different. Regular diode symbol, but then we get these two little tails put on the stripe. So with a zener diode, the way this is drawn, you know that if we want to pass current through it that way, if it was a regular diode, that would be okay. And with a zener diode, that's also okay. Current will flow through it in the direction of the arrowhead. But with a zener, we can also make current flow through it backwards, as long as we apply a high enough voltage to this side with respect to this side. So if we make this side much more positive than this side, we can actually force current to flow through the zener diode backwards, and that can be useful. So let's look at a situation where we have a DC supply, and zeners aren't usually used for rectification, for converting AC to DC. They're normally used within DC circuits. So here we've got a DC supply. Let's call that 9 volts. Remember, the long line here is always the positive. And we've got a resistor. And we've got a zener diode. So in this circuit, the current is always going to be flowing in that direction. And current will only flow if there's a high enough voltage across the zener. Now, how do we know how high that voltage needs to be? Well, the answer is it's usually written on the side of the zener diode itself. So let's imagine this is a 5 volt zener diode. And that would be stamped in tiny writing on the side of the diode itself. Well, what we find now is that because the rating of the zener is below the rating of the supply voltage here, current will flow. And if we put a voltmeter across our battery here, not surprisingly, it's going to read 9 volts because that's the voltage of this battery. And if we put a voltmeter here across the zener diode, it's going to read 5 volts. So this is our clue as to what a zener diode is used for. Whatever voltage is stamped on the side of the zener, as long as the supply voltage is higher than that, we can force a current to flow through the zener. But more importantly, the voltage across the zener will always remain the zener voltage itself. So in this circuit, 9 volt supply, but there would only be 5 volts here, which means of course that the other 4 volts would be here. So if we measure the voltage here, it says 5, measured here it says 4, and it gives us our 9 at the supply. And this is the normal purpose a zener diode is used for. It's normally used within electronics to give a voltage which doesn't vary. So in this circuit, let's suppose that the battery starts to run down a little bit. So we've left it on all day and the battery voltage has dropped down to 8 volts. This is just a smoke alarm battery, a little 9 volt PP3 battery. So after a while it drops down to 8 volts. The zener diode voltage is going to remain 5, and this will have dropped down to 3. 5 and 3 giving us 8. A little bit later again, the battery's almost dead, it's down to 7 volts. Zener voltage remains 5, this voltage goes down to 2. Battery drops to 6, this becomes 1, this is 5. However, once the battery voltage drops below 5 volts, there will no longer be any current flowing because we need at least 5 volts here to cause the current to flow. So if we wind back to the point where the battery voltage was, let's say 7, we can see now that as the battery voltage dropped from 9 to 8 to 7 volts, the voltage across the zener diode remained 5 volts at all times. And that means that if we wanted to charge our mobile phone from a 9-volt battery, we would know right away that the phone wants 5 volts DC, not 9 volts. If we built this little circuit, we could connect our phone across the zener diode, knowing that the voltage across the zener will also always be 5 volts, and this would charge our phone. We would also know that as the battery voltage drops from 9 down to 8, down to 7, down to 6, this voltage would stay constant, which is what our mobile phone wants. Must always be supplied with 5 volts DC. So the usual purpose for a zener diode is to give a constant voltage where that's needed. So let's recap our zener diodes. First thing is the symbol for the zener diode. Looks like a regular diode, but then these two little tails are the giveaway that it's in fact a zener. It has a voltage written on the side of it, and that voltage is the zener voltage. So that's the voltage that will always be across the diode whenever a current is passing through it backwards. And it's almost always used backwards. In other words, with the current flowing, as I've drawn it here, with the current flowing this way. And the most common use is to produce a reference voltage. So a point in your circuit where the voltage, although the supply voltage may change or the voltage at other points in the circuit may change, the voltage across the zener stays steady.